Good morning, good afternoon, and good evening from wherever you're watching this talk. I'd like to welcome you to our talk on weaving observability into the cloud fabric at Fidelity Investments. My name is Ronan Gilmore, and I'm an architect and team lead for cloud platform observability. And one of the primary focuses of our cloud team is we partner with engineering teams from across our enterprise, and we enable them to safely and securely adopt cloud at scale. And from an observability perspective, I suppose what that means is we ensure that as they embark on their cloud journey, they have the tools and capabilities available to them so as to ensure that they have high levels of observability for their platforms and services running on cloud. So I'm going to hand you over to Pete, and Pete's going to introduce himself.
Thanks, Ronan. My name is Peter Tamuk. I'm the lead engineer for Cloud Platform Observability, and my focus is on designing and implementing solutions to help our business partners around observability in the cloud.
Thanks, Pete. Great. So now that you've heard a little bit about ourselves, I just wanted to share a little bit about Fidelity, and in particular, how we've used technology and how that's evolved over the past 70 plus years, bringing us right up to today. So as you can see, around the 1960s, Fidelity purchased its first computer. Jump forward to 2016, and we deployed our first application in cloud. 2019, we launched a multi-cloud hybrid strategy. And in 2020, so far in this year, we have over 1,900 plus applications on public cloud and growing. So as we've embarked on that cloud journey, it's been awesome. And it's also introduced some complexity, particularly I'm going to focus on the observability space. So if we go back a little in time to where we had, or we still do, but where we have servers or VMs deployed on premise, and it wouldn't be uncommon for an engineer to log into one of those systems and tail log files or execute commands or look through log files to try and debug a problem, or if there was an ongoing incident. That worked reasonably well at scale in terms of those types of infrastructure settings. But as you saw from the previous slide, Fidelity's cloud journey is well underway, and when as part of that move to cloud, you have far more services, whether they be native CSP services or your own highly distributed services, a lot of serverless architecture, short-lived compute, that type of thing, and all of these components are emitting massive volumes of telemetry data, and that creates complexity around how do you consume that, how do you process that, and how do you use that data to reason about how the performance and availability of your services impacts your end users. And that's further compounded by the multi-cloud strategy. So add in more cloud environments, obviously you increase the levels of telemetry being emitted. So one of the approaches that we've taken to address this is by introducing what we call an observability first mindset. So when we do that, we need to think about observability up front. And that does often involve some cultural and kind of technology changes. So I'm going to talk a little bit about what does the observability first mindset look like for us. So a really good starting point here is working as a team, I suppose, to identify what matters to our customers. And like many of you, we are absolutely customer obsessed. We want happy customers all the time. And one way we can achieve that through observability is being able to identify when our customer experience might be going in the wrong direction potentially. And that is where having clearly defined service level indicators and service level objectives is a must. I'm going to leave it there on that topic because Pete's going to get a little bit deeper on that later on. And I'm going to jump on to the next important aspect of this, which is in order to have, now that you've identified your SLIs, you need actual data to in order to measure those. So that's where focusing on your applications and your platforms and services and identifying the key signals that you want to emit that will help you reason about your your service availability, performance, and health. So this is something, again, just like identifying SLIs and SLOs, it really should be a team effort. And as the team, you're responsible for, understanding what should be emitted and what are your SLIs and SLOs. Another really important area as part of this strategy for us is testing. And you can and you absolutely should test your observability. And by testing our observability up front, we have a much better chance to surface and remove blind spots. So for example, if I introduce latency into my system as part of a chaos test, does that trigger the expected actions that would ensure, in real time that my customers don't have a negative experience should that happen? Some of the things I might be looking for there would be, were my monitors triggered? Did my dashboards present that latency introduction into the system? And if so, did it help me get to the point in the system where the problem might have occurred? So really, really helpful to do that overall. This item here is about, if you have a production incident, and more often than not, that might involve some kind of postmortem. And, first off, we'll have looked at what the issue was, what was taken, was there some code change or a patch or whatever to fix it? That all gets taken care of. But then we're reflecting on it and thinking, what can we do to, avoid this type of scenario in the future, or at least alleviate the impact? So what we focused on here particularly is observability when we're thinking about this. To go back to the testing, did my monitors get triggered? Did my dashboards, were they effective during that incident? Am I emitting the right signals? Like, were we completely blind from an observability perspective during that? So you really want to kind of reflect on that and then address that going forward. So if you remember, the theme of this talk is about how do we weave observability into our cloud journey. And with that in mind, I'm now going to hand you over to Pete, and he's going to talk about what we've done to help our technology partners across the enterprise integrate with our cloud platforms and services with really a focus on observability. So over to you, Pete.
Thank you. Application teams are focused on introducing value to their customers, right? So by reducing the barrier of entry, we enable these teams to start getting value out of their observability and not letting it be an afterthought. Our team has introduced self-service capabilities, which allow engineering teams across the enterprise to easily integrate with our observability platforms, but I'll talk a little bit more about this in the next slide. Some other ways we help to reduce the barrier of entry is offering consistent agent deployments across all of our services. This includes daemon sets across multiple Kubernetes offerings to help build a commonality across these platforms from an observability perspective. Where agents cannot be deployed, such as serverless, we provide capabilities which allow our engineering partners to collect their telemetry without having to be concerned about how that happens. Additionally, for our public cloud providers, we automate the integration with our observability platforms. For example, Datadog crawlers on cloud accounts. We also create integrations between our observability platforms and our proprietary event correlation engine. This allows engineering teams to easily publish events to our notification system. One of the keys to having successful observability strategy is to have a standard around how the data is tagged and identified. Our team has made a large effort to create a set of standardized tags across all the cloud offerings and services. This helps keep This helps drive a common standard that users can take advantage of no matter where they choose to deploy their applications. So let's dive into the self-service a little. As I mentioned earlier, we want to make it as easy as possible for engineering teams to integrate with our platforms. We have implemented a set of observability APIs to abstract the underlying implementation, which allows engineering teams to easily consume our services. By abstracting the underlying APIs away from the users, it provides us greater flexibility should the implementation change, and also significantly reduces the effort required from engineers across the enterprise to consume our services. In this example, a user would like to create a data log index. They provide us a minimal set of data, and we take care of the various API calls that are required to create the roles, the indexes, etc. We also ensure that strict RBAC is enforced. Additionally, we enforce some standard rules around the types of log data that should be indexed. Through scheduled jobs, we examine all the log indexes and look for unauthorized changes to the default configurations. If we identify any changes, we are notified and we work with the engineering teams to address this. So around best practices, as Ronan mentioned, we are customer obsessed. So a great place to start when thinking about observability and how it relates to the customer is SLIs and SLOs. We have worked with our colleagues across the firm to identify a common approach to ensure that our applications, services, and platforms have well-documented SLIs and SLOs. A good starting point that we recommend for our engineering teams is to follow the Google SRE approach. So, for example, for a RESTful service, perhaps, one might use the golden signals. Beyond documenting, it's vital that these signals are collected and monitored. Around instrumentation, traditionally, there has been a heavy dependence on using logs to gain insights into applications. As we migrate workloads to the cloud, this does not scale well, and we need to complement this approach with other approaches. This is where we avail of different forms of telemetry, such as metrics and distributed tracing. As teams become more exposed to these approaches, we are starting to see that we have much greater visibility into what's occurring across our infrastructure. We continuously work with engineering teams to enhance their approach to logging. For example, we encourage them to use structured logs, which makes it much more efficient for processing and usage. As I mentioned, we also promote the use of metrics as signals from applications and services. Metrics are much more efficient to store, process, and visualize, and where possible, we encourage this approach over logging. Lastly, one key focus area is to design solutions that are technology agnostic. For example, we highly encourage teams to expose custom metrics in the Prometheus exposition format, which can be consumed by any backend that supports this open source format. Equally, we encourage the use of open source frameworks and libraries such as Open Tracing, Open Metrics, and more recently, Open Telemetry. Datadog has just released an Open Telemetry exporter for Python, and this is an example of an approach that we would validate and then provide to our user community. And with that, I'll pass the mic back to Ronan. Thanks.
Thanks, Pete. So I'm just going to briefly talk about some of our key takeaways so far in our journey. And I've already kind of touched on some of this, but just to go a little bit deeper. A key focus area for us has been chaos testing of our observability capabilities. So, there's a few angles to this. If we look at it from an application standpoint, and we look at this time series data down below. So this is where an example of, an application team may inject some latency into their system. And what we're looking for here is, was this surfaced through an observability platform such as Datadog? And if so, was there an action around that? So, was there some monitor that got triggered or whatever? So these are all the types of things you would be looking for should that occur, so that in a real world scenario where there was unexpected latency that your customers could be impacted by, that you would have that surfaced into your telemetry backend. As well as testing our application observability, we also want to test our telemetry system for failures. For example, what happens when our collectors fail? Do we lose data? Do new collectors get spawned? That type of thing. And finally, what happens when our telemetry backend is unreachable? So for example, here we're looking at our collectors, our aggregators, other components that may be on the telemetry journey. And we're looking at that from like a durability perspective, for example. How long can we keep going before data is lost if there's an issue with the network on the path to Datadog, for example, or if there's an issue with the cloud provider where our services are hosted. So whatever the case may be, there you're looking for how your system performs from a telemetry standpoint when there are issues. Another area that I'm sure many of you have reasoned about is how do you monitor the monitoring? And what we've done is we obviously have architecture diagrams of our systems from an observability standpoint, and we're looking for potential bottlenecks, whether that could be like maybe an aggregator tier, and what would happen if the downstream backend was unavailable, and what sort of back pressure do you have, and how does that impact your system overall? And one key area there that you're looking at is like ensuring that back pressure would never have an impact on the producing applications and services. You never want your business functionality to be negatively impacted by some issue with your collection, for example. Another key area to look at here is, for your agent collection, or if you're running scripts to collect or whatever, that you understand and characterize the resource utilization of those components. I would say particularly in Kubernetes environments, and we have quite a few flavors of that. You really want to understand, first of all, what limits you're operating under, and second of all, when you're doing so, depending upon the load that's coming from the other containers, we'll say, that are producers on your node, if you're running in a daemon set approach, then you really want to kind of be able to characterize how your collectors behave under heavy load, for example. And that leads me into the last point, which is stress testing your performance, or stress and performance testing your entire kind of telemetry collection and processing system from the point of collection all the way to the back end. And that's really important because this is, it is another system in itself, and you need to understand its ability to process large volumes of data, and also its ability to survive from a, and be durable should something happen at some point in that system. So I would say that's something that we put a lot of engineering prowess into, and it's a continued area of focus for us as we kind of evolve the system. Another area of focus for us is, it's probably an obvious one, but teamwork. Particularly in a large enterprise like ours, where we literally have thousands of engineering partners. We're very passionate about observability in our team, and we really feel it's incumbent upon us to evangelize why, if this is done right, what's important about it. So we know that it will protect our customers in the sense that they're going to have a better user experience from an availability and performance standpoint, if we have the right levels of observability across our applications and services. And to be quite frank, it will also make our lives that little bit easier as engineers if we have the correct kind of telemetry in place. Are we emitting the right signals? Are we collecting them appropriately? Are we processing them? Are we surfacing useful information from that? And that means that in the event of potentially customer impacting issues, the MTTR will most certainly be reduced. the mean time to resolution. We'll be able to get to the problems quicker. The next area that I'm going to talk about is providing reference implementations around accelerating adoption. So this would be, you heard Pete talking about, for example, that recent announcement from Datadog around OpenTelemetry and their Python exporter. So that's where our team would take that and create a reference implementation with one of our reference applications and make that available to internal teams so that when they try to adopt that, they have something to go on that will accelerate that adoption. Self-service and automate. So Pete's already talked about the self-service piece. Really important. At the end of the day, the application development teams and engineering teams, they don't wake up in the morning and the first thing they think about is observability. And that's fine. They have to focus on delivering business functionality for their users, but we want to make it as easy as possible for them to consume and use our services. And that's where self-service is really vital. And that's really what you think about when you think about operationalizing and productizing a service. Equally, from an automation standpoint, automate, as we've all become quite familiar with. In this space, we are talking about what can we do to automate, creation of dashboards or monitors, or how do we automate the upgrade and deployment of agents in various accounts or platforms or whatever the case may be. And finally, this is something that we started recently with one of the vendors we work with, Datadog in this case. And basically, this is about bringing together our engineering community on a weekly basis and helping them adopt at scale the capabilities that we're providing in this case around observability. So, it's a real hands-on keyboard problem solving and I think that the engineering teams have found it very beneficial because they leave there with a sense of, okay, I can now move on from that, or I know what I need to do to get over my next hurdle. Or more often than not, it's just people coming together and sharing and learning. And that's awesome. And that's what we like to see in terms of my first point, which was around the evangelizing why observability is important if done correctly. So that's it. We've reached the end. I hope that you've found this useful. We love what we do. We're passionate about observability, and we hope you are too. And all I'd like to do now is say thank you for your time on behalf of Peter and myself, and have a good day. Thanks.